Hello and welcome to this video where we're going to talk about advanced order of operations problems. And so what we're going to do here is focus on problems that really make you think about how you're going to do something in the proper order of operations. And so I have a couple of tips for you. First, be able to see the invisible parentheses. That's going to make life a lot easier. Second, know about different types of operations, so different types of mathematical things that we're going to have to do. And so, for example, I think what I want to do is I want to break it down to like 3 different categories for you. So we have big fractions. So we'll just label that as frac. And so what that means is we're going to have something where we're going to have a bunch of stuff here and a bunch of stuff here in the denominator, where essentially the numerator and the denominator are 2 separate problems, 2 separate order of operation problems. Now the catch here is to know that there are invisible parentheses around the numerator and around the denominator. So actually, let me do that in a slightly different color so that way we kind of pick that up. So we got to know where these invisible parentheses are. They're right here around the numerator and denominator, meaning we're going to focus on the numerator and then the denominator separately. The second category I want to point out are your square roots. Okay, and so a couple things we need to know about square roots is that if we have something next to a square root, there's an invisible multiplication sign. So if I say something like 3 square root, let's just say x, really what I'm saying is 3 times whatever is in my square root. Now, knowing about invisible parentheses, it's also helpful to remember that inside your square root is a set of invisible parentheses, meaning you got to zone in on all this stuff before you do anything else. Finally, before I get into some examples here, I want to talk about absolute value. So absolute value. And so that might be something, or that's these 2 tall lines right here. And then let's just say we have something like 5 minus 9. So again, there's sort of a hidden set of parentheses embedded right in here. And so inside your absolute value bars, you're going to treat those like parentheses, sort of. You're not allowed, or it's best to not try to bring anything in here. So don't do that. Focus on what's going on in here. And then essentially whatever is in here, when you get rid of the absolute value bars, is this going to become positive. So here we have 5 minus 9, absolute value of -4. In order to drop the absolute value bars, we're going to make it positive. So it's just going to become positive 4. All right, so now that we've gone over that, let's talk about some examples. So let me clean up my space. All right, and then big decision, what color am I going to go with? I'm going to go green. Why not? Okay, so first one, let's do a fraction problem here. So number 1, let's go with 4 plus 6 times 3, and then we have 21 minus 4 squared divided by 2. Now, a normal, quote-unquote, normal order of operations problem would just be either the numerator or the denominator. But we have to remember our invisible parentheses that tell us to focus on those 2 things separately. So, order of operations, I'm going to do 6 times 3, which is 18. I'll add 4 to that, and that gives me 22. And then my denominator, I'm going to square this to get 16 divided by 2. That's 8. Let's see here. 21 minus 8 is going to be 13. And that's it. So that's as far as we're going to want to take that problem because we cannot simplify it any further. Okay? Now, it might get to the point where sometimes these numbers might play well together. And so you got to remember that this could end up being 22 divided by 13. So if this was like an 11 or if this was 26, we could go a step further. But we don't have that, so we can't. All right, let's do another problem really quickly. This time, let's focus on a square root. So we're going to have 4 square root. Now notice how big that square root is. 3 squared plus 8 times 5. Now again, we have a set of invisible parentheses right here. I need to focus on that first before I can do anything else. So 4 square root, and then here I'll have 9 plus 40 will give me 49. Now, odds are, if we have a square root in the problem, whatever's going to be in the square root is probably going to be a perfect square. So now, when the square root of 49, that just becomes, whoops, don't need the square root anymore, becomes 7. All right? And if I kind of think about my invisible parentheses, I can bring them back, And then what I get to see here is I have that operation of 4 times the square root of 49, which is the same thing as saying 4 times 7, which is 28. I'll box it, and I'll walk away. All right, finally, let's do one more. I can probably squeeze it in right here. So number 3, let's do an absolute value problem. 3 absolute value, 5 squared minus 6 squared. Okay, so again, I have to know where my invisible parentheses are. They're inside my absolute value bars. So I'm going to zone in on that first. So I'm just going to copy my 3. And I got to remember that this is 3 times whatever I end up getting the absolute value of. And so that's going to be 25 minus 36. And so that's 3 times the absolute value of negative 11. I'm going to continue my problem over here. So now I'm going to take the absolute value. So absolute value essentially makes anything inside of it positive. And so that's going to make it 3 times positive 11, which is just 33. Now, we've got to be careful. Little warning. So let's do this in purple here. So let's just kind of put a little warning sign here. All right. So let's just say, hypothetically speaking, instead of it being 3 times the square root of negative 11, it's going to be negative 3 times the square root of, or sorry, not the square root, the absolute value of negative 11. So sometimes students think if you have an absolute value, it's going to automatically make anything positive. Yes, but only a certain part of it. Only this will stay positive. So I'm going to have negative 3 times positive 11, which will give me negative 33. So it is possible to have a negative answer. It's just that it's not going to come from the absolute value. It's going to come from something that's outside of the absolute value. So hopefully you kind of get how to do these advanced order of operations problems. Essentially what it boils down to is just being able to see the invisible parentheses and then knowing what more advanced operations would require you to do. So knowing how to do square roots, knowing what absolute value means. So good luck on your homework or practice, and let me know if you have any questions.